Hi everyone. In this video, we shall discuss mutually exclusive and complementary events in the context of probability theory. Now, mutually exclusive events are those that exclude each other. In other words, they cannot co-occur. For example, if you roll a dice and say a number 2 appears, then no other number can appear at the same time as 2 did. Therefore, the appearance of any one of the 6 possible numbers is mutually exclusive because that excludes any other possibility. Now, suppose we want to calculate the probability of getting a 2 or a 3 in the next roll of dice. So remember, we are considering 2 possibilities that may occur. They cannot occur at the same time. We are just considering the possibility that any one of the 2 outcomes may occur. So the probability of getting a 2 or a 3 is the sum total of their individual probabilities, which is 1/6 each. So the sum is 1/6 plus 1/6, which is 1/3. In general, we can say that if E1, E2, and E3 are 3 mutually exclusive events, then the probability of any one of them occurring in the next trial, that is, any one of them appearing, we are considering all 3, any of the 3 possibilities together, will be the sum of their individual probabilities. So this is in line with the earlier example that we have seen. Now, this is also reflected with this Venn diagram. The separate circles show that there is no overlap. Hence, they can never co-occur. Also, the probability of any of the 3 occurring is the combined chance of all of them. That is the sum of their individual probabilities. So based on the reasoning, you can work out some other scenarios. For example, what is the probability of getting a 3 or a 4 in the next roll of dice? You can pause the video and work it out and then resume to see the solution left on the slide for you. But here it is. The probability of getting a 3 is 1/6. Likewise, the probability of getting a 4, I hope you agree, is 1/6. So the probability of getting a 3 or a 4 in the next trial will be the combined probability, which is 1/6 plus 1/6, and it simplifies to 1/3. Similarly, you can work out the probability of getting a 3, 4, or a 5 in the next roll of the dice. So in this case, we are considering any of the 3 possibilities in the next trial. So again, the probability of getting a 3, I hope you agree, is 1/6. That of 4 is also 1/6, and that of 5 is also 1/6. Put all of them together because we are considering any of the 3 possibilities, and we just add the 3 probabilities, and this turns out to be 1/2. Now we come to the complementary events. Complementary events are a special kind of mutually exclusive events. To understand them, consider an example. Suppose the probability of liking maths in our class is 0.95 or 95%. Then what is the probability of not liking maths? Remember, the sum of probabilities equals 1. So hence the probability of liking and not liking must also equal to 1. Put together, that is. Therefore, the probability of not liking can be easily calculated. So the total is 1. We subtract the probability of liking, which is 0.95, and hence we get the probability of not liking, which is 0.05 or 5%. So liking and not liking are mutually exclusive because they can't co-occur. But that's not all. They are special kind of mutually exclusive events. That is, they are complementary events. And this is why the sum total of their probabilities equals 1. This means one of the 2 must occur. There is no third possibility. This is reflected by this Venn diagram as well. So where A represents liking maths, and A complements represents not liking maths. And together, A and not A cover the entire space of the Venn diagram. So hence, liking and not liking are complementary. One of the two must be true. For complementary events, the sum total of their probabilities, like I said earlier, must be 1, as is the case in this example. So here's another example. Suppose we toss a fair coin, where probability of getting a heads equals 0.5, because that's the definition of a fair coin. Then what is the probability of getting tails? Note, one of the heads or tails must occur. We discount the possibility that the coin can stand upright. Therefore, heads and tails are complementary events. This means that the sum total of their probabilities equals 1. So we can work out the probability of tails by substituting the probability of heads that's given at the top of the slide. Therefore, the probability turns out to be 0.5 for tails. Here's another example. Suppose we roll a fair dice. It's fair, so the chances of all the numbers appearing in the next roll are equal. For example, the probability of getting a 2 is 1/6. Then may I ask, what is the probability of getting another number beside 2? Well, you can get either a 2 or not a 2. So these two events are complementary. So we can get the probability of getting any other number beside 2 by subtracting the probability of 2 from the sum of the probabilities, which is 1. So 1 take away 1/6 equals 5/6. And which makes common sense as well. Obviously, there are 5 other numbers, so their probability out of 6 has to be 5/6. So with that, we complete this video, and we'll see you in the next one.